Well, it's the start of the last unit, Unit 8, the last one. Hopefully you're doing all right. Hopefully you are motivated. I know that's a little bit hard at times. Sometimes people are, you don't feel like there's sort of a light at the end of the tunnel. You need to kind of find a way to be disciplined and stay with this. Do a lesson a day. Try to do it during your regular class time. Find a way to stay involved. I notice some of you are kind of fading a little bit. We want to push hard to the end of the year. Okay, it says here, do the construct understanding on page 614. For those of you that haven't figured it out yet, the textbook follows along almost exactly the kind of lesson that we're doing. If you want a little bit of extra instruction, a little bit of extra guidance, you can go and look at what's going on in the textbook. It might help clarify something that we cover in class. Okay, but what we're going to do here is learn a little bit today about the absolute value. Okay, now if you remember earlier in the year we said like the absolute value is 2, the absolute value of positive 2, this is also 2. Basically what the absolute value does is it takes a number and makes it positive. We use the definition that how far is this number from 0? Well, it's 2 units. How far is this number from 0? It's 2 units. Okay, so if you remember that's what absolute value is, what we're going to do now is look at a graph. First of all, let's do the basic y equals x graph. You know this one. If x is negative 3, y is negative 3. If x is negative 2, then y is negative 2. If x is negative 1, y is negative 1, etc. Okay, this graph looks like this. Those are the points we just figured out, and then since this holds for any value of x, that's the graph y equals x. Okay, and now what we're going to do is take a look at the graph of y equals the absolute value of x. So what we're going to do here is take an x value, put it into the graph, and see what comes out. Well, if you put negative 3 into the absolute value of x, what happens? This is positive 3. Okay? If we put a negative 2 into x, what do we get? Positive 2 and positive 1. And then these will all be positive. So instead of drawing the graph over here, I'm going to put it on the same graph. You can see here these values are the same. Okay, so here these values haven't changed. But these ones, what was negative, and when I say what was negative, I mean the y values are negative. So for example here the y value is negative 3. It now becomes positive 3. Okay, and each of these points become positive. And so the absolute value graph is this, but it's also up here. Okay, it forms a V. That's the value, or the absolute value graph. Okay? Couple things about that. The absolute value graph has the form the absolute value of f of x. So when we do a graph, we're going to graph f of x and then we're going to take the absolute value of it, just like we did in this example. Okay, one thing to notice is what we call the critical point. The critical point is where the graph changes direction, and if you notice, that's always going to be the x-intercept. Okay, so the x-intercept is the critical point. Alright, so let's do another one. So we see here, this is an absolute value graph. What you should always do is graph what's inside the absolute value first, and then we'll take the absolute value of it. Now you should know this graph has a slope of negative 1. It has a y-intercept of 4. So I can draw this graph. It looks something like this. By the way, it would be useful to make sure you calculate the x-intercept, because that's a critical point on the graph. So x is 4, and that's what we have here. Okay, so that's the graph of y equals negative x plus 4. Now let's take the absolute value of that. Alright, the easiest way to do this is wherever the graph is positive, it will still be positive. Then at the critical point, we're going to take this and we're going to move it up there. Okay, and don't just do it kind of randomly. You know, take, what is this point? This point is 5, negative 1, so it would become 5, positive 1. Okay, and so then you can see where the graph is. All right, so that's how we're going to do the absolute value graphs. Graph the function and then take the absolute value of it. Okay, let's try another one. So let's graph this one using x-intercept and the y-intercept. Okay, the x-intercept, if you figure that out, is going to be negative 2. If you figure out the y-intercept, that's going to be 6. Okay, so the x-intercept negative 2, y-intercept 6. And that gives us enough to graph. Like so. Okay, now let's take the absolute value of that. Again, here's the critical point, the x-intercept. This part will stay the same. Okay, this part, where did I get this point? Well, since, oops, let's back that up. That point is the point negative 4, 6. I got that because I know that this is on the graph. Okay, now you're going to say, maybe, how do I know that? Well, if I looked at the original 2 points I graphed, this one and this one, I went 2 over and up 6, so I could go down 6, back 2. All right, the other thing you can see is that this graph here is symmetrical. So if I know that I'm going 2 this way, I'd go 2 this way. All right, try to make your graph as neat as possible. You don't want to just kind of go, oh, there's my graph. There should be some clear points that you're going through. Okay, so that's the absolute value. Now we're going to go a little bit further because we can also take the absolute value of a quadratic. Okay, so let's look at this first. If we put these values into this function, what happens? Okay, well, if I put negative 4 in, I'll get 16, take away 8, take away 3. So this will be 5. If I put in negative 3, I'll get 9, take away 6, take away 3. That's going to be 0. If I put in negative 2, I get 4, take away 4, take away 3. So that's negative 3. And then I get 1, take away 2, take away 3. So that's negative 4. Then negative 3. And then this is going back up. Okay, so let's graph that. What does that look like? Negative 4 is a 5. Negative 3 is 0. Negative 2 is negative 4. Oops, sorry, it's negative 3. Negative 4. Negative 3. Okay. Now, you guys should know other ways of graphing parabolas, right? You don't need a table of values. What you would do is you would say, hey, what's the vertex? What are the x and y intercepts? And you would graph it that way. The only reason I'm using table of values is just to show you what happens to the absolute value. If we put negative 4 into this, well, it's going to get a 5, and then the absolute value of 5 is still going to be 5. If we put negative 3 in there, you're going to get 0. The absolute value of 0 is still 0. But these three values, when you put them into the absolute value, you end up with 3, 4, 3, and then positive again. Okay? Let's just do one of those for example. Let's take negative 2. So you would have y equals the absolute value of negative 2 squared plus 2 times negative 2 minus 3. And that's all in the absolute value. Okay? So you're going to get 4, take away 4, take away 3. And so you would have the absolute value of negative 3. What is the absolute value of negative 3? It's positive 3. So what does this graph look like? Well, here are your critical values, the x-intercepts. This part was positive, it will stay the same. This part, all of the values are negative. Okay, so if we take them and make them positive, they'll come up here. And so you'd have the bottom of the parabola just flipped upside down. Okay, so let's try one like that. So before we can graph the absolute value, you need to look at this graph and remember, what does it look like? What is the vertex? That's easy. It's negative 2, 2. You can read it right off. Okay, we definitely need the x-intercepts. Let's find those out. So you'd have 0 equals negative 2 x plus 2 squared plus 2. So I think I'm going to use square roots here. I'll bring this 2 over there and then divide by negative 2. So it's going to be like this. If I divide by negative 2, I get 1 is x plus 2 squared. And now if I take the square root of 1 is plus or minus 1. And then if I subtract 2 from both sides, I'm going to get 1 take away 2, so that's negative 1. I'm going to get negative 1 take away 2, that's negative 3. Okay, so let's put this all in the graph. So negative 2, 2, there's the vertex. And I have x-intercepts at negative 1 and negative 3. Now hopefully that makes sense to you. If you know there's a parabola that opens down from here, you should know that it's going to be symmetrical and that the x-intercepts should be the same distance from the vertex on either side. So this looks good. Okay, the only other thing I should do is figure out what the y-intercept is. If I make x be 0, I get this. So you'd get y equals negative 2 times 4. This is negative 8 plus 2. So I get negative 6. Okay, and this will be symmetrical, so I'll have that point. There's the parabola. Now let's take the absolute value of that. Critical values, the x-intercepts. This part of the graph was positive. I don't need to move it. Okay, but these two pieces are negative. The y values are negative. So if I take the absolute value of them, this negative 6 becomes, becomes positive 6. And this negative 6 becomes positive 6. So I'll have a graph that looks like that. Okay, let's try one more. So you should pause right now, see if you remember how to do this. What's the vertex? What's the x-intercept? Okay. Alright, so after you've done it yourself, the vertex will be 0, negative 1. Okay, the x-intercepts will be, let's check it out. So I have 1 is negative 3x squared. If I divide by negative 3, I get negative 1/3 equals x squared. And if I take the square root of that, what's the square root of negative 1/3? That doesn't seem to make sense. Well, let's go and see what we've got here. We've got the vertex is 0, negative 1, and the parabola opens down. There are no x-intercepts. That's why this didn't make sense. Okay, so if we're going to open down, what does this look like? What shape is this parabola going to be? I probably need another point. Okay, so maybe I'll just take a little table of values here, and let's just pick x is 1. If x is 1, I get negative 4, and that gives me, it's going to be the same on the other side. So now I have a parabola. And if I take the absolute value, where are the critical values? There are none. What's positive? There's nothing positive. So I just have to take these 3 points and make them positive. So negative 1 will become positive 1, negative 4 will become positive 4. So this would be the absolute value. All right, we're going to stop there. I want to break this lesson into two because I think there's a lot to be able to do here. So let me just give you a couple of questions to try. Okay, homework is on page 621, and you can do numbers 4 to 7, 10, and 15.